In this video, we're going to be doing a Unit 5 rotational equilibrium practice. A uniform beam of 4 meters is supported at its center. A 20 Newton force is applied at one end, downward. What force must be applied to the other end to maintain equilibrium? So, for this question, this is going to be 4 meters, 0 meters. That will be 90 degrees. So that means that your center here is at 2m. You have to set your torque equal to 0. So your torque 1 will equal to your torque 2, aka your torque counterclockwise, is equal to your torque clockwise. So we can write our torque equation, which is 20 times 2, which is equal to F times 2, because we will have this other force here, and this is our mystery force. So your second force has to be 20 newtons, and that makes sense. So that's going to be 20 newtons upward. A 5 kilogram mass is placed 2 meters from an object. Where must the 10 kilogram mass be placed to balance the system? That's our pivot. So where do we place the 10 kilogram mass? So we have rotational equilibrium, and torque is equal to FR sine theta. So the block has a weight force equal to mg. So the force that's acting on the surface is going to be perpendicular. So if we draw it through the object, it's perpendicular like this. So your force is going to equal to the weight. And theta is equal to 90 degrees. So now you have to set your counterclockwise torque equal to your clockwise torque. We can see that if you push in, if you have something on this side, it's going to make the object go this way, which is clockwise. And if you have an object here, you're going to go counterclockwise, which is going to be negative. Or this is going to be negative, this is going to be positive. So we can write M1G1R is equal to M2GR2. So this is going to be your M2, that's your M1. 2 is going to be your R1. And here, this is going to be R2, but we don't know what that is. Now we can substitute in what we do have, though. So we have 5 and 2, and we have 10 and R. So we have R is equal to 1 meter. A beam is in static equilibrium. Which of the following must be true? When you have static equilibrium, you have the summation of forces is equal to 0, and you have the summation of torque is equal to 0. So that's answer A. A 6 meter beam is pivoted 2 meters from one end. So your total beam is going to be 6 meters, and you have your pivot at 2 meters. So that means the distance to the far end, this is going to be 4 meters, and 30 newtons is at the far end. So you have that torque is equal to FR sine of theta. So your force is going to be equal to 30. That's going to be C. Uniform beam is supported at one end and held horizontal by a cable at another end, which force provides the counter torque that balances the beam's weight. So the weight is equal to mg, and it's going to be downward. So this is going to cause a torque. A cable tension is applied at a distance. So the uniform cable is supported at one end and held horizontal by a cable by the other end. So the pivot force is here. There is no torque because R is equal to 0. So weight causes torque. Your cable tension, T, is going to cause your counter torque. So your answer is B. A 3 kilogram mass is placed 1 meter from the pivot, and a 6 kilogram mass is placed on the opposite side. And we don't know where the 6 kilogram mass is. So you have rotational equilibrium. Summation of torque is 0. So you have your torque counterclockwise is equal to your torque clockwise. And here that is same thing as earlier. We have our weight at an angle of 90 degrees. You can write this as M1 R1 because you have torque equals to FR sine of theta. Here it's equal to the weight times R sine 90. So it's equal to mg times R times 1. So our R's are going to be different. This is going to be R1. This is R2. That's M1. That's M2. Your G is going to be the same, so your G cancels out that 1. So you have M1 R1 is equal to M2 R2. If you plug in, you have 3 times 1 is equal to 6 times R. So 3 is equal to 6R. Therefore, if you divide both sides, R is equal to 1/2. And that's equal to 0.5 meters. So it would be at 0.5 meters. That's R2. A horizontal beam is supported at 2 points. If one support is removed, what must happen to replace the rotational equilibrium? When you have rotational equilibrium, the summation of your torque is equal to 0. If you remove one of the supports, torque is disturbed. The torque balance is disturbed. So in order to maintain our equilibrium, you must redistribute and rebalance your forces. A force is applied at a pivot point of the beam. What torque does it provide? Well, if you are applying it right here, the distance from, okay, so you have torque is equal to FR sine of theta, but if you have your lever arm is equal to 0, that means this whole entire thing will just equal to 0. A uniform beam has a weight acting at its center. If the pivot is moved closer to one end, what happens to the torque due to the weight? Well, we know that if you have a beam, if you have a pivot and your pivot is closer to one end, like your pivot is here, we know that here your torque is equal to FR because your force is already perpendicular, so you don't need the sine theta. R is your distance from pivot to center of mass. If you move your pivot closer to one end, this is going to increase your distance from the pivot to center. So that means that if R increases, that means that your torque is going to increase too. Two equal forces act on opposite sides of the pivot at equal distances but in opposite directions. What is the net torque? So one is this way, one is this way. We can see that it's going to be 90 degrees, so sine theta is going to be maximized. So here, they're going to push the object to go counterclockwise in both directions. So you would just, because they're in the same direction, you can say that your net torque is equal to torque plus torque, aka 2 times the torque. So it's going to be doubled, 2x.